welcome to what's new in Geographic Calculator 2020 Service Pack 1. My name is Sam Knight. I'm the Director of Product Management here at Blue Marble Geographics. I'm here with Scott today.
Hi, I'm Scott Weber. I'm a QA analyst. I'll be trying to field some of your questions as we progress.
And today we're going to be talking about Geographic Calculator. So if you're new to the Geographic Calculator, it is really the application that started Blue Marble all those years ago. It's centered around coordinate conversion and data transformation. We're a very specialist geodetics package. We're known for our large database of coordinate reference systems, datums, transformations, very comprehensive support of all things geodetic. Today we're very happy to be talking about our latest service pack update that we just released actually yesterday. We went live with it. It's available on our site for download at any time. We've got a few things that we're going to be talking today about how we've extended some of those functions and really some interesting developments in the field of geodetics as a conceptual level that are now working their way into the calculator from some new standards that are evolving. Before we get going, the format of today is a webinar format. All attendees are in a listen-only mode. We do have a questions panel. You'll typically find that on the right-hand side of your screen. Feel free to use that to send in any questions. We'll try to keep an eye on that as we're going through here. We'll maybe respond directly to some of those in text. We'll take some of those maybe out loud if it's something that pertains to everyone. And we'll also save some time for questions at the end. And as usual, this session is being recorded. So anything that maybe you miss or you want to go back and take a look at later, we'll probably have this session posted to our YouTube channel typically early next week. It takes us a few days to clean up the video and get it posted up for sharing. Also, upcoming, this series of talks are short webinars. We've been calling GeoTalks Express, and these are actually sort of more abbreviated versions of what we cover in our full-on GeoTalks sessions. This is a really exciting day for us. It's once a year we put on a full-day conference. This year it's coming up on January 27th. In 2021. This is sort of our first big deal of the year. It's a full day of presentations, product updates, tips and tricks. We actually feature user presentations as well as talks from Blue Marble folks about features of our various applications, SDKs and things like that. Registration is open for GeoTalks. You can visit the link at the bottom of the page there. It's just bluemarblego.com/BMUC. You can also get there right from our main website. You'll find some links to sign up and register for that. It's always an interesting time, and I'm not just saying that as a Blue Marbler. We have some very interesting users that present on various topics throughout the day. As well, we also have, particularly timely for our calculator release here, we have some training classes coming up on Geographic Calculator. Like many things this year, we have gone fully remote with these, so this will be an online class. It's not just on the Geographic Calculator. We do actually start with some applied geodetic concepts and then apply those in the Geographic Calculator. So we talk about all the basics of things like datums, ellipsoids, linear units, angular units, transformation methods, vertical datums, and so on, all the nuts and bolts that you need to really get to work in a geodetics package. We apply this through the Geographic Calculator. This will be one cohesive class broken up over 4 two-hour sessions. That's going to be running from January 20th to the 21st. Excuse me, correct the date there, 2021. So that's coming up in January, obviously. And sign up on that on our website again, bluemarblegeo.com/training, if you'd like to find out more information about that. So today we're going to be focusing just on the Geographic Calculator and specifically the new features that are found in 2020 Service Pack 1. We're going to take a quick overview of the application, just sort of the very basics for those of you who might be new to the tools. We're going to take a look at a brand new tool that is accompanying Geographic Calculator, and this is an online component of the tools. Then we're gonna dive back into the desktop platform, and we're gonna take a look at some of the new IOGP data model updates. These are some really sort of interesting conceptual changes that are coming from new ISO standards for how we define things in geodetics and how these are working their way into the Geographic Calculator. There's a lot of under the covers changes in Geographic Calculator at the service pack release. There's a number of things users may not notice right away, and there are some things that are definitely right up more in the forefront. We'll be taking a look at how these data model updates are going to affect your everyday work. We'll take a look at a couple other new features as we're going along, and we will again hold some time for questions at the end. So please feel free to send your questions in via the questions tool. And if we don't answer you immediately in there, we'll try to get back to that towards the end of the session. Now let's hop over here into the Geographic Calculator. I think that's coming through. Scott, you still clear on seeing my screen?
Looks good.
All right. So here we are in Geographic Calculator. I'm running the 64-bit version of the application. Many folks come to us when it's time for a new version and say, oh, should I be on the 32-bit or the 64-bit version of the application? We do recommend the 64-bit version of the application. There is essentially complete parity between 32-bit and 64-bit. Most modern machines are 64-bit in their operating system. And you will find that it is simply a little bit faster. It's able to chug through a little bit more, and it takes advantage of increased memory on the machine. So it's able to actually address all of the memory you have on your PC if you're running particularly heavy jobs. So anything that we see here today will be available in both platforms, but 64-bit is our recommendation. I've started here on the interactive conversions job. So the interactive conversions job is really, it's kind of like the heart and soul of the application. It's where we take one single coordinate and we transform or convert that to some other coordinate system, some other geodetic reference frame in some other units. What we're going to see here as an example translates throughout all of the rest of the applications. And if you're looking down the left-hand side of my screen, you'll see there's a number of different things over here. First, we're going to focus just on this stuff up at the top. So these are the basic types of jobs that we have, and everything I have in the special features category down here are sort of like special combinations of particular data types and particular data sets that are combinations of the settings that are available to us in these base job types at the top. So the interactive conversions job, again, it's just focused on one particular type of point at a time. I've entered in a coordinate here that's just a nice simple sample coordinate. Anybody that's attended our webinars before has seen me use this coordinate. This is off in the woods somewhere near where we are here in Maine. I've got a coordinate system already set up on these, but we're going to take a very quick look at selecting coordinate system. I'm just going to double click on the blue box down here labeled system, and I'm getting a pop-up on another screen. There we go. Asking us if we'd like to focus this in by geographic area, or if we just want to simply browse through the entire list of coordinate systems ourselves. So first I'll say yes, and that's going to pop open our map control. And we have some tools on here. We can define a point. If we want to say where we're working on the map, you can click that anywhere around the globe, and that will then deliver us a filtered list of coordinate systems. I'm going to cancel that, and if we go back in there again, typically the way I work is I know exactly what system I'm looking for, so I'm going to say no, and instead I'm going to use the categorized tree view list here that shows us the entire thing, gives us our search tools, and it allows us to break these down into categories of things like geodetic or projected coordinate systems, and then geopolitical organization beneath that. So if I'm looking for something like our common NAD27 coordinate system here in the States. We'll find that at the North America level because it covers the entire continent area. If I'm looking for systems that apply to smaller regions, I might just click the United States, and then I'll see things that only apply within those areas. If I have any question about the definition itself, once I see a particular thing, such as our NAD27 system here, I can just right-click on that and say, view the information. And that's going to open up a definition panel, and that will give us all the things like identification, how we find that in other databases, what the definition actually is, and any history associated with that if there is history notes present from the EPSG database, where many of the coordinate systems come from. So we can use this information to be totally sure of the particular system we're looking for. We're going to come back in here in a little bit and talk about some of the changes in here. Anybody that is a longtime user of the calculator is already noticing some differences on this page, and we're going to come back to those and talk about usages and scopes a little bit later on. So taking our system, coming back to the main screen here, now we have our coordinate systems. I did the same thing to select our output system. And what I need to do is establish a coordinate transformation to relate those two systems to each other. So we're going to be going from NAD27 to NAD83. Now in the database, there's a whole lot of ways that we can do that. And by double clicking on the coordinate transformation box in the center, this is going to help us generate a filtered list of only those transformations that apply to the coordinate area that we've punched in for our data here. So if I hit all of them, we'll see everything that's in every category down here on the left. And you'll see I've got about 5 ways that I can do this. There's various information about the methods that are used, the area of use where those transformations apply, and so on. All the same information is available. All that identity information is available if we right-click on one in particular and say View Info. That's going to, again, pop us open a definition panel where we can see all the nuts and bolts that makes that a particular geodetic definition. I'm going to grab on to our new NADCON 5 definitions here. These are the new survey standard for the United States for moving between NAD27 and the various epochs of NAD83, and come back to our main screen here. You'll see the method is listed off in the coordinate transformation box, and then all we have to do is go on and click calculate, and that will give us our final result. There are many other pieces that we can get into moving between various epochs if we're doing work in more modern frames. If there are time-dependent transformations, you'll see we have some date boxes that are optional down here. If we're trying to do things like move between some of the ITRF-based systems and their continental counterparts, things like the NAD83s here in the States, and things like ETRS-89 in Europe, the various GDAs in Australia, and so on. So there's a lot of complexity that we can add on in here. I'm going to take one of the questions that I see coming in on the fly. Why did NADCON 5 not show an accuracy when we selected that in the tree view? Let me just back up and we'll take a quick look at what that was, what that's focusing on there. So if we look at all of them, you'll see there is an accuracy column running down the middle. The accuracy for any of our sort of more historical datums, things that are not brand new, things that come from the EPSG database, are all published with a particular relative level of accuracy. And the accuracy is essentially like the confidence that you have in a particular transformation, since transformation does change the data. A viewer here has pointed out that we don't have an accuracy listed for NADCON 5. NADCON 5 transformations are not yet found in the EPSG database, and so we don't have that composite answer ready to go for those. Under the hood, that information is there, and it's something we're working on figuring out a way to properly expose in the Geographic calculator. But the longer answer is that every single transformation that passes through NADCON 5 has a a different level of accuracy for it. It's all very, very good, and it's all tighter than the previous NADCON methods. But we don't yet have a simple way to extract that out point by point in the calculator toolkit. So that function should be coming hopefully in the near future as we get a little more time on NADCON 5. So coming back out to our main job, you'll notice that I've been poking around in the interface here, and when I came back to my main job, all of the text turned red in here, and that indicates to us that I've made some kind of a change. I've been touching stuff and maybe changing settings, and so it's warning me that that my coordinates may not match if I selected a different transformation. Something I see in this chunk is no longer matching what I had before. In this case, I picked the same system, but it does detect that I've been climbing around in there, and it's possible that I did something that's going to change. So if we want to clear that up again, I can just hit calculate, and it will give me the exact same result. We can try various methods for moving between those and calculating our results. Those are the main nuts and bolts of how we operate throughout the application. So where we see a lot of difference is not in the selection process for the coordinate systems. These blue boxes we'll see on all of our various interfaces around the application. What is going to vary is as we do things like look at different types of data, such as the point database conversions, which I think Scott's going to take a minute and talk about here.
Yeah, so the point database conversion job is set up similarly to the interactive, except if you have tabular data, where your columns are uniform and all of the data in your columns are on the same coordinate reference system, you can import tabular data such as Microsoft Excel or open document spreadsheets, DBase files, all the different text files, comma separated, tab separated, space separated, and even ODBC databases. So here we have an XLS file loaded, and you then can select down in the input columns which columns you want to use for your northings and eastings in this case. And they're northings and eastings because the coordinate system in that similar box to the interactive job is set to WGS 84, UTM zone 19 north. If you had a geodetic system in there, then those input columns would be labeled latitude and longitude. You can also add a vertical coordinate system, and then the third pop-up or third drop-down would appear in that input for elevation. Then you can select the output columns. The output columns can be to existing columns in the spreadsheet, or you can add new columns. In this case, we're using two existing columns, latitude and longitude. Now in this job, we have not set up an output data file to write to. So we have a data field at the bottom there, similar to our input. That is blank at the moment. We can just preview the data. So without setting up an output file, we can display in the data grid above what the results are. So Sam has hit preview, and the latitude and longitudes are populated in there. If we want to write that to a file, we can add that file name, hit process, and it'll write us an output file with those same data. Oh, and on output formats, we can write to the same output as we have input options, but we can also write to some vector formats such as AutoCAD files, DGN files as well, Esri shape files, KML, KMZ, or map info formats, among some others.
Number of formats down there. And as you've been talking, Scott, I saw a question come in about what's the best strategy to handle point database conversion that involves millions of points. Is there any kind of a limit on this interface?
Yeah, well, theoretically, there's no limit to the amount of points you can enter in. There used to be a limitation on XLS files, but there's no longer a limit on that. So any length of file should be loadable into the job.
Yeah, the XLS limit, I believe, has to do with the file, the specific version of Excel, right? I think it's the old one that has it's a limit of about 60,000.
Yeah, so if you're in like a Excel version of like 97, Office 97, that may have the limitation on it. But if you're in one of the 2000s versions, then with the XLSX extension, then you should be unlimited.
Right. And how about ASCII data formats? We got any limitations on those?
I do not believe so.
Yep. So the tools will actually pop up if you try to load an extremely large file. We have a threshold of about 100,000 where you'll get a warning when you load, and it will say, looks like you're trying to load a whole lot of data, and it will give you an option to partially load the data or to fully load that data. And if you partially load the data, you'll see the preview tools. You can just do some tests on the top chunk of it, and then run the entire thing out directly to file without bothering to load it all in the spreadsheet. I believe historically the largest data we've been told about from a customer was an ASCII data file. And if I remember, I believe it was a seismic horizon file, and it was about 30 gigabytes of ASCII data in a single data file. So there are no practical limitations here other than how much storage space you have on your machine. The process that we go through for loading an extremely large file is actually the same as loading a small file. We just go one coordinate at a time, and so it's actually a very simple process for a computer to handle.
And if you know that you have a large file and are concerned about how long the load time might be, and you just want to see what the data looks like, even right within the job, there is a checkbox up in the upper right labeled Only Load, and you can check that box and then specify how many records you want to display in the grid. When you go to process that file to output, it will actually process the entire file, but you can get a preview of what the file contains by using the Only Load feature.
Yep, and let's see. And while we're here, I just saw another question come popping in. How did we do this transformation without choosing a transformation method? That's a good question. If you notice on the left-hand side, we have a base geodetic here of WGS84. And on the right, we actually have the same coordinates system. So this is going from a UTM zone 19 projection that is based on WGS84 to a lat long. So geodetic, not any projections involved here. But it is also on WGS84. So that particular operation doesn't require a transformation. That's what we just simply call a conversion. The only math that's actually being done is getting us from UTM back out to a basic latitude longitude. So that is an exact conversion rather than requiring a transformation method, which is what we would select in the middle there. Okay, so moving on. Let's see. This was the point database conversions job. And you'll notice there are actually 4 other types of point database conversion, and they all do particular operations. So we have things like point database forward calculations. So taking a starting position and moving away from that by a distance in azimuth and calculating the ending position. Likewise, we have inverse operations. We have scale and translate operations. These are where you do a manual transformation using something like a coefficient multiplier to do your data transformation instead of a conventional something like a 3 or a 7 parameter transformation. We have best fit operations as well. These allow us to map up local ground grids against geodetic controls, as are very commonly used in mining grids. Some oil fields have these, airports, any number of types of projects might have a local ground coordinate system that needs to be mapped up. Datum transformation derivation, so where you have 2 unknown or two known systems, but there is no known transformation between them, we can use those control networks and calculate a transformation between those. And then a few more specialty things down here at the bottom. So seismic survey conversion is something that's very, very popular in the calculator in the seismic survey industry. Not really a surprise there, but seismic survey data has a number of very specialized table formats. It's very, very largely ASCII data, very massive files. They get into millions and millions of points. And the work here happens much like on the point database conversion job. It's just a little more streamlined because these are more rigidly formatted files and so on. So there's a number of different ways we work with point databases and tabular data structures. Just wrapping up the basic job types here. Vector conversions and raster transformations. I'm going to kind of talk about these both at the same time because they're fairly similar. Within the vector data job, here it's a very simple interface. It's just a file path in and a file path out with our similar coordinate system handling boxes in the middle. Here you'll see I have a sample file, and this is a vector file of towns here in Maine. So this is in one particular projection. This allows us simply to reproject that file out to some other coordinate system, and at the same time, if we wish, we can change the file format. So this is a shape file coming in. We're converting that out to a DWG file for use in AutoCAD. Any of the various vector files that we have in there, we can select for output from that. So mixing and matching both the coordinate systems and the data structure itself. On the raster transformation job, very similar in appearance, except here we just simply have the extra piece of adding in the reference raster reference information, how we geolocate a particular pixel. So that has its own file, and there is actually a complete georeferencing tool built in to the Geographic calculator. So this allows us to establish that pixel to world relationship if you have freshly scanned data or raw aerial photos and you need to do a manual reference to establish that image to world relationship before doing the transformation and rectification on that. There's a number of specific features around each of those types of data format. Whether that is, pixel settings, things that are like background colors, layer operations, if we get into vector data and such. But each of those is really a fairly comprehensive coordinate handling tool. It's just how the various types of data come and go at it. Now, so far, these are the base types of jobs. We're going to come back and talk about a few of the special features here. But one of the main new features that we have in Geographic Calculator this year is actually not in the calculator itself. So we have an entirely new tool online. And so this is a web browser we're looking at right here. So this is the Geocalc online geodetic registry. This is a tool we've had for a few years now. I think we're coming up on 3 years of this tool being out in the world. We just completed an overhaul of this, and we actually have our previous webinar session was on a deep dive on the Geocalc online tools. So there is one main new tool here that is available to all users of the Geographic Calculator, and that is a calculation tool online. So you're no longer confined to your typical desktop working environment. All users of Geographic Calculator for the year of 2021 are going to have access to the online tools to try that out as we establish the online calculation tools and get those running. This is likely to transition to some type of subscription in the future. But we want to get that out there in front of folks this year. So the base part of this are our search tools. These are the chunk that we've had for quite a while. I'm just going to sign in here real quick and come back to our search. so we can see some of these tools. And you'll see the search tools are really very parallel path to what we have in the desktop. We have an optional map search here on the interface. You can click a spot on the map and do a quick search to find what is in that area, and it will categorize all of the geodetic definitions in that particular area. Or we can go back and use a text search, and you'll see my good old standby search of 4326 if I'm searching for WGS 84. We can come back to that and find all of the various bits and pieces in our search, whatever type of object those are going to be. So off the home screen, again, either doing our search for, so I'm stuck in my browser. There we go. So however we get down into those search results, you'll see all of the various pieces that we have. So individual coordinate systems, individual transformations, a little farther down in the list there, depending on what criteria we've given that for a search. If we're signed in, this portion of the application. If you are signed in, you'll have some additional functions. And so the sign in for this is simply a Blue Marble website account. So if you've ever downloaded anything from us, you've already got a website account. If you are associated with an order, you've also already got a website account with Blue Marble. If you're signed in, you have access to do things like print the definition on a nicely formatted page, export those out to various types of file format. And throughout next year, if you are also associated with a calculator order, you'll have the additional functions of working with our new converter tool. And so this allows you to take a quick search and use that as the source or target for a conversion. So let's move over there. And I think, Scott, you're going to talk about calculation here, right?
Yeah, so the calculator item in the menu there takes us to what we call the point-to-point calculator. And basically, this performs 3 different types of calculations directly in Geocalc Online, just as you would in the Geographic Calculator's interactive conversion job, which Sam had covered at the very beginning there in the calculator interface. And if you can recall that job in your mind, this looks very similar to that. We have a source coordinate point that you can set up. Sam's going to enter a point in North America, Maine, 4470 West, and he's going to select, I believe, NED 27 for the source coordinate system, and then NED 86 for the output or target coordinate system, or NED 83 2011. That'll work. Okay, and one thing to note, in Geocalc Online, you do need to enter the source coordinate point before you can select the target point coordinate system. So with those entered, then we can select a transform, and we can use the NADCON 5 transformation that is suggested there, and then hit calculate. So this is virtually identical to the interactive conversion tool in the calculator app.
So all those. Go ahead, sorry, Sam. Go ahead, Scott.
I was just going to say that, note that we do have the 3 radio buttons in the upper right for the 3 different kinds of conversions that you can do interactively. So you'd pointed out the forward inverse point database job, and we have a forward and an inverse version of this tool as well, as in addition to the point converter.
Yep. So what I was just going to say there was for folks that are wondering why I didn't actually have to pick a transformation, there is an extra piece of logic here in the online tool where if there is only one transformation that is available, it will auto select that and put it into the center box for you. You can still look that up, but in this case, for this particular combination to get between NAD 27 and NAD 83 on the 2011 version of that datum, there's currently only one method available, and that is this new NADCON5 method. And in the center box here, you'll see for the datum transformations, you'll see all of the various steps that single transformation actually has to do. So it's actually going to be doing 5 things at once to move between all those various epochs of the datum to get from the starting coordinate system to the target coordinate system. This again is available to any calculator user throughout 2021. You do need a Blue Marble website account in order to get access to it. So the first step, if you don't have a Blue Marble website account, you simply go to bluemarblegeo.com and register for an account there. Or if you go to geocalconline.com and you're not already registered, there's a registration link there as well. Right now, we're in a free for anybody to try kind of phase. So absolutely anybody can try it out right now. Through 2021, it's going to be anybody with a current calculator subscription has access to the online converter tool. Anyone can search, but doing the actual conversion work is going to be limited to calculator users. And if you do have a Blue Marble website account, you can sign in and you register, and you get a warning that says you need to sign in with an account that's associated with a calculator order. It may simply be that your web account is not linked up with your order. So if you contact our orders team or your sales contact or the tech support team, any of us can get you pointed in the right direction, link up your web user account against your existing order, and we'll get you on your way. There are a number of folks who may not have that connection. If somebody else does the ordering and you use, say, a network license, you maybe don't have a Blue Marble website account of your own. But this is a free for 2021 to any calculator users. So reach out if you have any trouble getting access to it, and we can get you going. So that's a pretty exciting new tool for us. And I'm just gonna take that back off screen here and bring us back to the desktop tools. So now back to the real ads here in the desktop tools. So Scott, we've got some pretty interesting updates that have come down the line from IOGP and OGC and EPSG. We have a lot of alphabet soup with some pretty cool new geodetics behind them.
Yes, we do. So IOGP has adopted the ISO 19111 2019 standard from OGC. That is started in EPSG version 10.003, which this Service Pack 1 is up to version 10.007, so we're current with that. And they've added some new data models, including something called usages and scopes, which Sam will get into a minute, dynamic datums, and datum ensembles. So I'll let you take it from there, Sam, and describe those 3 things.
Okay, so these are some interesting new developments in geodetics. I'm going to start with usages here. Usages is actually a kind of a catch-all for a couple of things. So for those of you familiar with our library here for a while, you're probably comfortable with the term area of use. So an area of use is simply it's a geodetic definition of where either a coordinate system or a transformation applies on the planet. So we've got a number of things here that are regional descriptions. It's how we organize our database to begin with. Things like North America onshore, or say Peninsular Malaysia or East Malaysia and West Malaysia together in various regional descriptions. They exist for every single coordinate system in the database. And essentially it's a bounding area. There are two types of definitions. They have a rectangular definition that is a minimum bounding rectangle of whatever that area is, as well as a polygon that more tightly wraps the shapes of all of those areas. So those have evolved, and so instead of just being an area of use, they're now calling that a usage, which is not just an area of use, but it also encompasses an intended purpose within that area. So it's getting a new level of granularity. And it makes for some handy reference for somebody doing geodetics work that needs to really dive into it and do that next level of research to make sure that they've got exactly the right thing thereafter. So here in the usages list, you'll see we have a very long list, and these names, if you're familiar with our database, they're going to look a lot like the area of use names. And that's essentially because the areas of use in the EPSG database published by IOGP, all of those names were moved over into this new idea. So I'm just going to crack open the very first one in the list here of Afghanistan. And you'll see that a usage contains an area of use. So that name is Afghanistan, and the scope is our other new entity, and the scope is geodesy. So the scope tells us our purpose, and the area of use tells us where. So it's if you're, say, a military user, you might find some scopes in there that say military use, and those have maybe differing levels of accuracy than somebody that is trying to do, say, traditional land cadastre work, where we need a very, very fine level of accuracy. So to take a look at this, I'm actually going to step back out here, and I'm going to work with a blank definition. So this is a blank usage, as if I were setting this up for the first time. We would pick an area of use, and that has a description of the area, and then it has a bounding rectangle for that area. And then we would also select a scope. And so the scope gets a lot more purpose driven. And you'll see there are various ones here. The first one alphabetically on our list is Abu Dhabi Municipality GIS. That is a very specific sort of purpose within that area of use. This tells us who adopted this particular scope, and then it would also have that area of use to tell us within this particular city of Abu Dhabi for municipal GIS is the purpose of that particular entity. There are a number of more sort of generic ones, such as approximation at the 1 meter level. You'll very often see something like that associated with a transformation between two coordinate systems that are extremely similar. As we get down a little farther, you'll see things like cadastre in particular countries or cadastre or engineering survey. Really a very granular level of definition for what these things are used for. To the everyday user, if you're just going in, going out, you know exactly what coordinate system you need, you're probably not going to need to dive down into these. Where these are going to be most useful is for that user who is doing geodetics research. Maybe you have a historical document and you're trying to get all the way down in the weeds to make sure you've got the proper historical reference for an entity. So those are the usages and scopes. And then the other new entities are a little bit different. So we're going to hop over into our datum definitions here. So our list of datums, this is exactly the same as you're familiar with seeing. So we have all of our particular datums, but now when we go to define a new datum, as a part of that definition, you'll see there are additional possibilities here for a datum. So we have our typical ellipsoid and prime meridian definition, and that's been our previous limit. That's been all we needed to define a datum. But now we have some additional types. So we have basically nothing special. We have a dynamic datum, and we have an ensemble. Now these are various things. All of the sort of datums we've had up until this point have all qualified as none. There's nothing additional for that datum. Dynamic datums are an interesting piece of geodesy. They're laying the groundwork for stuff we're going to do in the future. When you have a dynamic datum, you have this possibility to define a frame reference epoch. And this tells you not just where a datum is, but it tells you when that datum is. So increasingly, modern coordinate systems are acknowledged to be models in motion. So we know where they are at a particular time, but we're also modeling how they move through time. So the frame reference epoch basically tells us where the data for this particular model was time-stamped. So we know when to move things through time to go from one system to another that may exist at different times and are going to actually need a temporal transformation, a shift through time, as well as a shift through space to move two systems together or transform from one to another. The dynamic datum, the funny thing about it is it's not going to do anything for us right now, but it's going to lay the groundwork for point motion models that are going to be coming to us through the ISO 19111 updates. Those are going to be increasingly where we see dynamic datums such as the North American terrestrial reference frame. That's going to be the new datum coming for North America here in the States and used throughout the reaches of North America. There are other dynamic datums being developed all around the world, both horizontally and vertically. The concept of a vertical dynamic datum is geodetically really quite interesting. So the dynamic datums are going to be built on in the future. It's something you're going to see now as we get ready for that. And it should be pretty neat stuff as we move on. The last new piece here is ensembles, and I'm going to let Scott talk about that for a second.
Okay, ensembles are just a grouping of usages or of related coordinate systems or datums. So WGS84 would be a great example of that. So we have the original WGS84, but we also have some other realizations of it moving through time. So we can now have an ensemble for WGS84, the WGS84 ensemble, that lists all the various realizations that have occurred through time. And so it's just a nice way of organizing the related datums into one grouping or ensemble.
Yep. So those are going to be another thing that is kind of interesting to see how those groupings evolve in the database and how those come together with transformations. Right now, it's essentially a shorthand for saying these are all essentially the same thing at different points. They're essentially interchangeable, and depending on who you are, that is more or less true. Some folks are very concerned with the individual differences between the various realizations of something like WGS84. Other folks working at much lower accuracy levels, doesn't particularly matter to them. But this is another new piece that's going to allow folks to have a much more comprehensive and interrelated set of definitions. It allows us to do all of the neat things a database can do with our geodetics objects as they interrelate into each other, and all the nuts and bolts of how they work together. So all of these new pieces, again, many folks are going to find that these may be sort of more under the hood changes, and they don't really affect your day-to-day. But these are the types of things that are going to be coming along to us as new coordinate systems evolve. It's going to allow us all to stay current with our geodetics and work right on that front edge of geodetics technology. Let's see. So, Scott, I think we were going to wrap up by talking about some of the other new things for folks who maybe haven't even stepped up to 2020 yet. We added a number of kind of neat new features earlier this spring in Geographic Calculator. You want to remind us of a few of those things?
Sure. So the first thing I'll mention is that with the coming of COVID-19 and the work from home movement, which we here at Blue Marble are doing ourselves, we realized that we needed to make it possible for people to work over remote desktop protocol, RDP. So we now have a license capability that's RDP enabled for working at home or away from the office. And that was new as of the spring. On another note, we added the new US geoid model of 2018. So that's been in there. And I think the prior one to that was 2012B, other than some experimental geoids that have come and gone along the way. So you find that
There's our
there.
Geoid 18. A lot of folks were asking for that. Folks still ask for that.
Yep. We've added 2 new magnetic declination models. So if we look at our interactive job, maybe Sam, you could turn on magnetic declination for, that's a preference that we can enable. And right in the preferences, we have a selection of models to choose from, and the WMM 2020 is new, and the IGRF 13 is new. And just a note on those IGRF model numbers, those have nothing to do with years. Those are just version numbers. So 13, I can't remember the exact years, but it's relevant from like 2020 moving forward or something to that effect. So it's somewhat equivalent to the WMM 2020. WMM 2020 is the default when you first enable that option. And then that'll allow you, when you're doing a conversion, it will tell you in your coordinate system what the magnetic declination is for that point.
Yep, and an interesting note we all learned together when we were working on those is they're actually based on the same data sets that those are derived from. The WMM 2020 looks into past data, and the IGRF models are basically forecasts into the future. So one is historical and one is forward-looking. They all have very narrow time windows. The WMMs are all about 5 years, I believe it is.
I believe so, yeah. Okay, and the last new thing that's new to 2020 is support for early bound coordinate systems. Now, if you're not familiar with early bound coordinate systems, what that basically is a way of binding a coordinate transformation to a particular coordinate reference system to force you, when you select that system, that you're going to use a particular transformation associated with that. If you think of our interactive job here, we were able to select a source and a target coordinate system, and then we have that transformation box in the middle. That's called a late bound transformation, or late bound coordinate system, where we have to pick after the fact what transformation we want to use to get from the source to the target. But sometimes we may want to force, due to business enterprise rules, we want to make sure our users are using a particular coordinate transformation every time they select a particular coordinate system. And so we can take a coordinate system and tie it to a particular coordinate transformation. And then each time you select that early bound coordinate system, it will automatically basically fill that center box with the transformation that's bound to it. So do you have an example there, Sam?
I was just walking through the process of early binding a system, and I was off on another screen. That was what happened. And so what we end up with is there's our new area of use. We have the base system that we selected. So I early bound the NAD 27 lat long system, and I attached a particular transformation to WGS84 for that system. So that then becomes a new entity in the list there. If I click off of that, you'll see it's going to show up as blue without the padlock, indicating that's a custom definition. And if I go to do a transformation between NAD 27 and WGS 84, that will come up as an option in a special category called early bound. Scott mentioned that this is useful for largely for business rules type applications, and that is mainly going to be its use. The choice of that it is actually a choice. It's not like it's not an exclusive. It's not there's only one right answer. It depends a lot on the business that you happen to be working within and the standards you're using, what you need to match, and your various internal processes for how you want to qualify things. Some folks may have a geodetics team that would fully step through their database, early bind one transformation to every system they work with, and then shut off everything else. That would be sort of some of our more advanced enterprise users might do that kind of operation. Other folks might use that. I'm actually going to use this as a tie-in between Geocalc Online. Some folks who may use a internal version of our Geocalc Online tools may have a whole library of early bound coordinate systems that they manage through Geocalc Online that come and go from other geodetic software packages that they're mapping up. So there's some very specific uses for the early bindings of the coordinate system, and I'll just take one more note on these. This function is actually switched off by default, so it is a administrative geodetics preferences option you'll find in the admin tools. If you want to use that, you need to turn it on before you'll see the option to early bind coordinate systems, just because that's not the kind of thing that is necessarily for everyone. I'm going to use that sort of as our final segue to talk about Geocalc Online, one last piece of this. So Geocalc Online, we do also have professional services based around the public-facing tool that you see on geocalconline.com, our website. That also has a behind firewall option. So we can set these up as professional services within your own private cloud environment, and it allows you to fully customize the contents of that database, fully manage all the access to that, various things like user level access based on your own authentication services that you have internally, white labeling that as your own enterprise specific branding, and all of the things that come with managing your own internal database, how that ties into other software that you might have, other geodetics parameter databases that you have across some of your various packages, and so on. So there's really a lot there, and if you are working at a large enterprise that has an extensive coordinate system library, maybe it's custom, maybe you just use things that are EPSG predefined, but you have a more specialized list of those. It's definitely worth a look at our new Geocalc Online tools for how those work within your own cloud environment. So if you've made it this long with us, we thank you for hanging on. And I think let's take a look at if we have any last minute questions that have come in here. Scott, can you see the questions interface at the moment?
Yeah, there's a question about Geocalc Online about after 2021, how we'll be able to access it.
Oh,
so
okay.
Talk about
yeah,
the
so
search versus calculator.
I think I mentioned I mentioned a few times that throughout 2021, this is going to be free for anybody that is a current calculator user. Basically, we're giving ourselves this first year to let folks try it and get it out in the world and make sure that folks like the way that works. After 21, we are probably going to introduce some type of subscription model that would add on or augment to your existing calculator subscription. We view it sort of as an add-on functionality beyond the what you can do in your base application. But we do want to pay attention to all the folks that are asking us for cloud functionality of these various tools. So there will definitely be options to have access to it. We're still working on exactly what that's going to look like after this first year. I know that's kind of a vague answer, but it will very likely take the form of some type of subscription model that may be built into various levels of subscription with the geographic calculator.
There's another question about putting in different magnetic models other than the ones that we already have in there, like HGDM models.
Oh, let's see, HGDM, if I remember, I think that's like I believe that's some kind of high definition model, if I remember, very, very fine resolution. I remember reading about that one. There are a few models that are out there that we are interested in adding that are, I believe they're based on a paid access model. Many geodetics grids that are out there, whether it's a horizontal transformation or a vertical transformation, many of those products are typically published by governments and they're typically released for free. And if that's the model I'm thinking of, that might actually be a paid model, and we're going to need to look into how we can make that available, or if we can make that available. But I'm going to step back one level and answer that more generically. If there's any type of coordinate system specifically that you're interested in your day-to-day workflow that you don't find in our database, please let us know about it. We add things all the time. We have the most comprehensive database available of geodetics parameters. We aim to keep it that way. And so if there's anything in there you find yourself wanting to use that's not there, let us know about it. Send us whatever information you can, and we'll do our best to find if we can implement that new model.
Okay, you also have a question. Who is eligible for the upgrade to the service pack?
Oh, of course. Should have mentioned that a while ago. So the service pack, this is a service pack release. There is no license change between this package and the initial 2020 Geographic Calculator 2020 package. So if you have Geographic Calculator 2020, you are eligible for the service pack. It will simply drop right in place with the same license that you have on your machine already. If you have a previous version of Geographic Calculator and you are still under an active subscription, you are also eligible. And basically the short answer is anybody that has an active maintenance and support subscription on whatever version of calculator you have. If you're staying on an old version for some reason, maybe IT reasons for staying on something that's not 2020 already, as long as you have an active maintenance subscription, you are eligible for the upgrade, whether that is a single user or if you're in a network environment or dongles. There is no change to the license. So if you've already got a functional 2020, it should be very simple for you to upgrade. We would encourage you to do so. If you do have a previous version that is being supported under an active subscription, so if you're on say 2019 or 2018 or something even older, and you've still got an active session for that's under a support contract, you're also eligible, but you will need to get a new license file from us. So I would encourage you, if you're moving up from something older, definitely check in with us, make sure your license is good, and we can help you migrate up to this 2020 service pack one.
I just want to say I will review the questions that have come in. I think we've done a pretty good job of addressing them, but if I have not gotten to your question, or we have not, I have your email address and we can get back to you shortly. Okay.
Okay, sounds good. And now we're getting some comedy questions in from our developers. So shout out to our developers. Great job on this release, guys. And other than that, I think that's going to wrap it up for today. So thank you everybody who's attended, who's still hanging on with us here. Thank you, Scott, for presenting with me today.
Very welcome.
And we'll see you next time.